Amazing people. What we've got here is we've got an example of 3D trigonometry and also 3D Pythagoras theorem, where we're being asked to find the size of angle AD. Now, what we can do here is we can start to draw out some different triangles that we have in this shape in order to be able to find AD. So the first of these we're going to do, since this is a cube, is we're going to have an isosceles triangle where we've got those lengths there. And so this side is going to be equal to this side here. And so this is going to be A, B, and C. And this will have a length of 2 meters here and 2 meters here. Now, in order to be able to process this and find out the length of AC, because AC is going to be essential for us to work out the length of AD, what we are then going to do is we are going to use Pythagoras' theorem. And so that's going to be AC squared here is equal to AB squared plus BC squared. And as we do the substitution into this, this is going to be AC squared is equal to 2 squared plus 2 squared. We go further, AC squared is still going to be equal to 4 plus 4, so that's going to be 8. And a step further, we've got AC, this is finding the square root of both sides of this. This is going to give us the square root of 8. And we can apply some of our surd rules here. And what we'll end up with is we'll end up with 2 root 2. Now, what we want to do is we want to now apply this to another triangle. This one is not going to be an isosceles triangle. It's just going to be a right angle triangle here. It's going to look something like this. So this is our right angle triangle here. And what we need to do is we need to start to apply some information to it. So in this case here, what triangle we have, this is going to be A, this is going to be C, and this is going to be D. Now, we already know that DC is going to be 2 meters. We can see that in the original diagram of the cube. The further information we have is we do know the size of AC. Now, the best one to use here is I'm going to use root 8 to help me here. We could use 2 root 2, but root 8 is probably the best at this point in time. And so what we're seeking to do is find the size of length AD. Now, again, we can apply Pythagoras' theorem here, and we're going to have AD is equal to, in this case, we're going to have AC squared plus CD squared. Substituting into this, AD squared is going to be equal to root 8 squared plus 2 squared. Going further, this is going to be 8 plus 4, which gives us 12. So that's the square of AD. What we need is to find the square root of this. So AD by itself is going to be equal to root 12. And if we apply some rules here, this is going to end out to be 2 root 3.